Okay, guys, Bismillah ar-Rahman ar-Rahim. We are starting chapter number 7, and this chapter is about correlation and regression analysis. And what is correlation and regression? We will, with the help of these two methods, we can identify the relationship between two variables. This is also called the bivariate analysis. So in bivariate analysis or in two variable analysis, we will check that how two variables are correlated. So we have so many examples in the business field and other sciences where we have to investigate the relationship between two variables. So two things we would do: how two variables are connected, what is the direction of the relationship, and second thing that we will investigate, that what is the strength of the relationship between two variables. So these two methods, correlation and regression, they tell us that how these two variables are connected. So one variable is always an independent variable, and other one is depending uh, upon um, upon the independent variable. So independent variable, usually the convention that we use for independent variable is x, and for dependent variable we use y. So always we use the same convention. Okay, uh, the independent variable is independent. Okay, it is not depending upon anything, any other variable. But the dependent variable can be changed by changing the independent variable x. Okay, so as x changes, y will change. Okay, and but changing y, okay, by changing y doesn't means that x will change. Okay, it doesn't guarantee that x will change. X could change, but it doesn't guarantee that by changing y x will change. But if you change x, y must change. Okay, now the two methods that we will have in today's lecture will be correlation and regression. So what is correlation? Correlation is a number. Okay, it tells us two things. The first one is the strength of the relationship between two variables, and second thing is the direction. So correlation is a method which provides us a number, and that number will give us two things. Okay, that number will provide us two information: the strength between the relationship of two variables and the direction of the two variables. Regression method, on the other hand, is a method which provides us a mathematical form, a mathematical equation between, or you can say the mathematical relationship between two variables in the form of an equation, like y equals to a plus bx. So it provides us the relationship between x and y variable in this way. With the help of regression method, we can predict. Okay, prediction or forecasting could be done with the help of regression method. Both methods, they have their own advantages and disadvantages. We will discuss both the things in this analysis. So in today's lecture, I will just concentrate on the correlation method, and the next chapter we will discuss about the in the next lecture we will discuss about the regression analysis. Okay, now before starting the correlation, you must know three things. Okay, the first one is the arithmetic mean. Okay, how to calculate? Okay, you must know, because we need the mean again and again in this analysis. And the standard deviation. Okay, how to calculate? Okay, I told you in the previous uh, course as well, that try to calculate the standard deviation on your calculators. Okay, you all have the built-in feature of calculating the standard deviation on your calculator. So try using that thing. Okay, so you must know how to calculate the standard deviation using your calculator. So the formula is this one: x minus x bar, its square sum, and dividing by n minus 1. So this is the sample standard deviation. Okay, third thing is the covariance. Okay, the covariance is how to calculate, and what it tells us is it tells us about the linear association between two variables. Okay, it will tell us about the direction. Okay, only the direction. It will tell us that direction means that if x increases, y will decrease or increase. Okay, by increasing x, okay, what happens to y? If y
Increase.
decreases, okay, if y decreases, this is called inverse relationship. Okay, this relationship is called inverse. And if y increases, this is called the direct relationship or positive relationship. Okay, so the covariance tells us the direction only. It will, whenever we get some answer here, suppose we get here 20. Okay, so we have to look at the sign. Okay, if it is positive, then we say that there is a positive relationship, there is a direct relationship. If x will increase, okay, if x increases, the y will increase. And if x decreases, y will decrease. But if we get here a negative answer, suppose we get a answer to be -10. Okay, so this indicates that as x increases, y will decrease. So there is an inverse association between x and y. So covariance just tell us about the direction. Okay, it tells us about the direction of the data. And how to calculate? We just take the deviation from the mean, multiply both the deviations, and then we just get the sum and dividing by n minus 1. So this is the formula for covariance. And its positive value indicate that you have positive or direct relationship. If you get a negative covariance, so this means that you will get a negative or inverse relationship between the two variables. Okay, magnitude of the covariance doesn't matter. Okay, it tells us nothing. Okay, for example, you get here positive 20, or you get, for example, positive 200. So the magnitude doesn't mean anything. Okay, so magnitude doesn't signify anything. Okay, so we just look at the sign. Okay, whether it is positive or negative. So covariance, we have to look for its sign, not its magnitude. Magnitude is not important. Magnitude is important in the case of correlation. Okay, we will discuss about that, but here we just look at the sign only. Let us calculate. Okay, so here we have the example. uh, Look, there are many phenomena in business in which we see two variables. Okay, and one variable is depending upon other. So this is one of the example. Look, here we have the temperature for 6 different days. Okay, we recorded the temperature for 6 different days. And suppose we have a business of ice cream. Okay, so the sale of ice cream is recorded at the 6 different days. Okay, when the temperature was 14 degrees centigrade, the sales were 3 liters. Okay, when the sales were 18 degrees centigrade, when the temperature is 18 degrees centigrade, the sales were 7. When the temperature is 20 degrees centigrade, the sales were 8. So when it was 22 degree, and we get the sale 10, 21 degree we get the sale 14, and the last day we recorded the temperature 25 degree and the sales were recorded to be 18. Okay, now you can see here, as the temperature increases, you can expect, you can see here the sales are also increasing. Okay, so overall we can say that there is a positive relationship between two variables. But sometimes from the table it is not easier to calculate that thing, but here it is clear. So let us calculate covariance and the scatter diagram. Okay, scatter diagram is a simple thing. Okay, so let us calculate the scatter diagram first. Okay, so here you have to take x, and here you have to consider y. Okay, so scale x. So you can see scaling x. Okay, look here, one thing at the beginning of the question, because x and y will not be provided, that which variable is x and which one is y. So you have to use your common sense, okay, to identify that which variable is independent and which is dependent. Use your common sense and general knowledge. For example, look, can sale change the temperature? Okay, sales cannot change the temperature, but temperature can change the sale. Okay, means temperature can change your sale, but sales cannot change the temperature. Okay, temperature is a natural phenomena. We cannot control the temperature, so temperature will be considered as independent. Okay, and sales will be considered as dependent variable. Okay, so once you identify that which variable is x and which one is y, then we move ahead. Okay, so here we, on the horizontal axis, we take the independent variable, and on vertical axis, we take the dependent variable. And now we just scale. Okay, you can see the minimum temperature is 14, maximum temperature is 25. So we have to take the temperature accordingly. So we started from 14 and 16 and 18, then 20, then 22, and then 24. And here you will have 26. Okay, so on the vertical axis you can see the minimum cells are 3 and maximum is 18. So if we move in this way, 3, 6, 9, 12, 15, and here you will have 18. Okay, now when the temperature was 14, the cells are 3, dot, put a dot. Okay, when the temperature is 18, the cell is 7, put a dot. When the temperature is 20, the cells were 8, you put another dot. When the temperature is 22, cells were 10. And when the cells were 21 here, 21 is here, so cells were 14, this one. And when the temperature is 25 here, the cells were 18, this one. So in this way, we can see this is called the scatter diagram. It tells us, it shows you the overall behavior as x increases, what happens with the y. Okay, so overall you can see they are increasing. Okay, now we have to calculate the covariance. So for covariance, according to the formula, you need the mean of both the variables x and the mean of variable y. Then you have to calculate the difference between both of them. So let us calculate the difference from the mean. So the mean of x is 20 and mean of y is 10. So let us calculate the difference first. First of all, the deviation from the mean: 14 minus 20 minus 6, 18 minus 20 minus 2, 20 minus 20, 0, 22 minus 20, we get 2, 21 minus 20, 1, 25 minus 25. Okay, so these are the deviation from x. Okay, the x deviation from the mean. So let us calculate the y deviation from the mean y. Okay, so 3 minus 10. Okay, the mean of y is so 3 minus 10 is 7. 7 minus 10 is minus 3, and 8 minus 10 is minus 2, and so on. Okay, so you just calculated the deviation from the y mean and deviation from the x mean. Just multiplying both of them, we get the total here. Multiplying these two, we get 6. Multiplying these two, we get 0, 0. Okay, 4 and 40. So adding all the product. Okay, so this product you will calculate, the total is 92. Just put this. So this is summation of this product, 92. Dividing by 6 observation we have, and is 6. 6 minus 1, we get 5. And 92 by 5, we get this covariance. So we just see here it is positive. So if it is positive, we can comment that there is a positive relationship between x and y. If the temperature increases, the sales increase. Okay, if the temperature increases, the sale increase. If you get here a negative answer, you can comment that if the temperature increases, the sales will decrease. Okay, so you have to just look at the sign. If it is positive, comment accordingly. If it is negative, inverse relationship. Okay, Now look at the scatter diagram that we constructed here. Same sort of diagram we have here, computerized graph here. Okay, now you can see here there is a clear increase. Overall trend is increasing. Okay, so overall the sales are increasing with respect to the temperature. As the temperature going up, the sales are going up. So this is the overall trend. So you can see here slight decrease. Okay, there is slight decrease as from 21 to 22. Okay, as the temperature increases from 21 to 22, the sales are decreasing, but we have to look overall. What is happening overall? So overall, if we see that overall these points are increasing. So if at 1 or 2 points the sales are decreasing, we cannot count. Okay, we don't count that decrease. Okay, so we can say that overall there is an increase in the sale with respect to the temperature. Let us consider another example. In this example, we are given the sales of boots and their prices. Okay, so sales of boots and their prices. So according to the law of demand, price and sale, they are inversely correlated. Okay, as the price goes up, the demand goes down. Okay, so according to the law of demand, price can be considered as the independent variable, and the sales or the demand will be considered as the dependent variable. Okay, demand is depending upon the price. So this is y and this is x. So once we assign x and y, we can start the question now. We have to calculate the covariance and the scatter diagram. So covariance requires mean of x. So you just get the total, adding all of them here. Okay, get the sum. Sum is 180, and sum of this one is 90. Dividing by 6, we get the mean x to be 30 and mean for the y to be 15. So once we get mean x and mean y, we can just take the deviation from the means. So we just make the table x minus x bar and y minus y bar. We calculate it again in the same manner. We multiply both of them and we get here a product. Multiply these two, we get here a product. Multiplying minus 5 and 3, we get here minus 15. 0 multiplied by minus 2, we get 0. And in this way, we get the product. And adding all of them, we get here the sum. Sum is minus 445. Okay, divided by n minus 1, which is 5. Okay, so we get here a negative answer, minus 89. Minus 89. So it indicates that the price and the sales, they are negatively correlated. Okay, so the relationship is negative. Covariance is negative. So this means that as price increases, the sales will decrease. Okay, so this is actually the what we do in the covariance. Now, this is the scatter diagram, and now you can see here that there is a clear decrease in the sale as the price goes up. Okay, so overall the sales are going down. Okay, now actually in the covariance, what is the problem? Problem is, look here at the beginning, I told you that we have to investigate two things: strength and the direction. Okay, so direction we have in just address this thing. Okay, covariance just address direction only. What about strength? Okay, how to get the strength of the relationship? Strength means that how two variables are correlated, means as x increases, y, how much it will increase or it will decrease. Okay, so what is the, how strongly two variables are connected? Okay, so the strength can be identified with the help of correlation coefficient. So here we will calculate now to identify the strength, the measure of strength. Okay, it will be calculated with the help of Pearson correlation coefficient. There are two types of correlation coefficients. The first one is called the Pearson, and second one is called Spearman rank correlation coefficient. So this one we apply on the rank data. Okay, so if you have the rank data, then we apply Spearman rank correlation coefficient. On the normal data, we apply the Pearson correlation coefficient. Okay, on the normal data we apply the Pearson's correlation coefficient, but on the rank data we apply Spearman rank correlation coefficient. And one more thing, we have to analyze Pearson correlation coefficient and the Spearman rank correlation coefficient in the light of scatter diagram. Okay, we have to look both the things, correlation coefficient with scatter diagram. Okay, this is must. We have to plot the scatter diagram to see the overall trend inside the data, and Pearson correlation coefficient as well. It will give you a mathematical measure, okay, about the relationship. So we measure the correlation with the help of correlation coefficient plus the scatter diagram. Both are important for the analysis. Okay, now the first thing is the Pearson correlation coefficient. In today's topic, I will just cover Pearson correlation coefficient, and Spearman rank correlation coefficient we will do in the next week. Okay, what is the Pearson correlation coefficient? Pearson correlation coefficient is just a covariance. Okay, it's just a covariance divided by the standard deviation of x multiplied by standard deviation of y. So if you divide the covariance by standard deviation of x and standard deviation of y, we get the Pearson correlation coefficient. And always keep two things in mind. Okay, whenever we get the correlation coefficient, you will check two things. Okay, first one is the sign. If your answer is positive or negative. If it is positive, the positive answer will indicate that there is a direct or positive relationship. If your answer is negative, this indicates that you have inverse or negative relationship. Second thing that you need to check, your answer must be, okay, your answer from here must be within this range from -1 to 1. If your answer is outside this range, you need to check your calculation because you did a mistake. Okay, you made a mistake if your answer is outside. For example, here the Pearson correlation coefficient comes out to be -1.6. So check your calculation. You made a mistake because your answer cannot go beyond this range. Your answer must be inside this range. Okay, so if your answer is close to 1 or -1, you will say that strong relationship. And if your answer is close to 0, okay, suppose you made suppose here you have -1, here you have 0, and here you have 1. So if your answer is in this area, okay, you can say there is no relationship. If your answer is here in this range, you say strong relationship. Here, no relationship. Okay, and in this range between here, you can say moderate or weak. Okay, I will tell you the ranges. Okay, so here you have moderate or fair or whatever. Okay, so in this way you can comment on the answer that whether you have a strong relationship, weak relationship, or no relationship whatsoever. So you will comment accordingly. Okay, now we will calculate the correlation coefficient, Pearson's correlation coefficient, with the same example as we solved the sales of ice cream and the temperature. So let us apply, because we already calculated the covariance. The covariance was 18.9, I think 18.9 was the covariance we have. Now we just need to calculate the standard deviation of y and standard deviation of x. So once you calculate, and I told you earlier that you must use your calculator to calculate the standard deviation of the data. Okay, use your calculator. So But if you don't use calculator, you have to use the formula, and the formula for standard deviation of x will be, it is x minus x bar square divided by n minus 1. So this formula requires, first of all, you need to take the deviation from x, then take its square, okay, get the sum. Okay, so sum is 70, so divided by n minus 1, which is 5. So you get here the answer to be 14. 10 and yes, 14. Okay, so in this way. And similarly, if you want to get this standard deviation of y, so you have to divide this thing by 5. Okay, and then you will get the standard deviation for y. So dividing the covariance by the standard deviation. Okay, so here we get the variance. Okay, so you have to take the under root to get the standard deviation. Okay, so here we get the variance, and now taking under root you will get the standard deviation. Okay, so here we get the standard deviations for both the x and y variables, and dividing 18.4, which is the covariance. Okay, 18.4 divided by the standard deviation of x and standard deviation of y, we get the Pearson correlation coefficient. Okay, so uh, this is the Pearson correlation coefficient, and it will tell you two things. First one is the direction, because your answer is positive, so this indicates that there is a positive or direct relationship between x and y. X will increase, y will also increase. X will decrease, y will decrease. Okay, so this is called the direct or positive relationship. Second thing that it will provide you is the strength. Okay, if your answer is closer to 1, okay, you can see here 0.9 is close to 1. So we can say here, if it is close to 1, the correlation seems to be strong. Okay, the correlation, if your answer is close to 1, the correlation will be strong. Okay, now um, you can see here the figure is same as we had in the previous example, the scatter diagram. So we look at the correlation coefficient, and here we have the figure. So by looking at both of them, we are now sure that there is a strong positive correlation between x and y. So both things we have to look before we taking the decision. Okay, before taking the decision, look at the both figures. Okay, this figure and the answer you get for the Pearson correlation coefficient. Okay, now look, there is an alternate formula as well. Okay, either you can use this formula for Pearson correlation coefficient, or this is the expanded form of the same thing. Actually, this formula is time consuming. Okay, if you apply this formula, this is time consuming. Okay, why it is time consuming? Because first of all, you have to calculate x bar, you have to calculate y bar, then you have to calculate the standard deviation of x, standard deviation of y, then you have to calculate the x minus x bar. Okay, then you have to calculate y minus y bar, the column, then you have to take their squares. Okay, then you have to take their product, x minus x bar multiply by y minus y bar. So if you apply this formula, you have to calculate 1 2 3 4 5 6 7 8 9 9 things. Okay, 9 things should be in your hand before you apply this formula. Okay, so it is time consuming. So to avoid this time consumption, we use this alternate formula. This formula will be provided to you in the exam. Okay, but it can save your time if you don't apply this. Looks easier, but it is time consuming. Okay, this formula is very simple to apply, very easy, but harder to memorize. So we will provide you in the exam this formula. If you want to apply this formula, it will be provided. Look, how many things do we need in this formula? This product xy, okay, x square, summation x square, and summation y square. Rest of the things will be given in the question. For example, summation x you know, summation y you know. Okay, so everything you have, you just need three things: this product, summation y square, summation x square. So just three things. With the help of these three things, you can apply the formula. In that case, okay, in this one, you need all these things. Okay, so because we want to save our time, so that's why we prefer this formula. Let us apply this formula. So x and y, they are provided in the question. So calculate x square. Okay, 14 square is 196, 18 square 324, 20 square 400. Similarly, calculate y square. 3 square is 9, 7 square is 49, 8 square is 64, okay, 10 square is 100, and so on. And now calculate this product xy. So multiply these two. 14 into 3, we get 42. 18 into 7, you get 126. 20 into 8, you get 160, and so on. Okay, get the sum of all. So once you get the sum of all, okay, just put inside the formula. Okay, rest of the thing is just, it will be done by your calculators. You just plug the values in, and at the end you will get the solution here to be the same solution you will get as you got from the previous formula, 0.923. Okay, so 0.923. So you can comment in the same manner. Okay, in the same manner you will comment that we have positive strong relationship between x and y. Okay, so in this way you can analyze the results. Okay, so we have for the second example, you can also do the same procedure. You have the price and the sale. Okay, so what you would do, you will just calculate x square, y square, x multiplied by y, and you get the sum of all. And at the end, you will get you just plug the values inside the formula. Okay, do this calculation, use your calculator to do these calculations. Okay, and at the end, you will get the answer to be minus 0.962. So because of this negative sign here, okay, what you will answer, there is an inverse relationship, an inverse strong relationship, because it is close to -1. Okay, it is close to -1. So you can say that there is inverse strong relationship between x and y. Okay, then you will look at the scatter diagram as well. Okay, so that you can have idea that yes, there is a strong relationship. The scatter diagram also indicates that there is a strong relationship between two variables. Yes, Abdullah.
Doctor,
Yes.
is there a difference between strong and moderate?
Yes, I will tell you. Okay, I will explain that what is the difference between the strong and moderate or weak or no relationship. Actually, we have four categories. Okay, we have four categories to identify the strength. Okay, so let me take you to that thing first. Okay, so let me take you to that thing. Okay, so how we categorize, okay, how we categorize the correlation coefficient results. Look, uh, whenever whenever you get an answer in this range from zero point 0.9 to 1, okay, from zero point 0.9 to 1, if you get this answer in between this range, this is called strong. Okay, and similarly, if you get answer from minus zero point 0.9 to -1, okay, so in this range, if your answer is in this range, this is also called the strong. Okay, second range is, it starts from zero point 0.6, okay, till 0.89999. Okay, if you have your answer in this range, okay, this is called moderate. This category is just below this strong. Okay, just below strong you have the fair moderate category. Okay, so this is called moderate, fair, normal. Okay, the third category starts from it starts from 0.3 to 0.59999. Okay, this is called weak category. Okay, this is below than this moderate category. We have the weak category. Okay, so this indicates that still there is a relationship. Okay, there is a relationship, but this relationship is weak. Okay, there is a relationship, but this relationship is weak. The final category that we have, if your answer is from 0 to 2.99, sorry, 0.29. Okay, so 0 to 0.29, this is called no relationship category, or you can say negligible, or no relationship second category. Okay, so if your answer is from you can say from minus 0.29 to 0.29. Okay, so this whole category is negligible. Okay, negligible or scant category, so you can say no relationship. Okay, you can simply say no relationship. Okay, so same thing happens for the negative side as well. Okay, same answers for, but you will just say that negative, 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 weak, fair, moderate, and strong. Okay, so in this way you will read your answer. Okay, you will comment on your answer by looking at. Okay, so you need to memorize this range. Okay, the complete this table you have to memorize, so that whenever you get an answer in these ranges, you have to comment accordingly. Okay, now the last thing in this lecture that I want to explain, actually, one important thing. Look, whenever we get the Pearson correlation coefficient as a number, okay, don't take the decision. Okay, don't take your final decision based upon the Pearson correlation coefficient. Okay, you have to look at the scattered diagram as well. So as I told you earlier, that both things are necessary for the final decision. Okay, we have to look at the scattered diagram as well. Here scattered diagram shows the same thing, but sometimes it is not so. You have a different thing from here, and you see here a different thing here. In this example, both are same. Okay, point we get 0.9, and here we see that strongly they are going down. Okay, they are strongly going down. So this means that there is a we can take the decision that there is a strongly negative relationship between x and y. Okay, now I will give you few examples in which Pearson correlation coefficient will tell you different thing, but the scattered diagram will give you a different thing. Okay, so the final decision is based upon looking at both of them. Okay, so now look at this one. Okay, look at this one. Here the scattered diagram of the data that we have, it shows that the all points, they lie on the straight line. Okay, they lie on the straight line. Okay, the Pearson correlation coefficient tells us about the linear association. Okay, always keep one important thing in mind, that the Pearson correlation coefficient tells us about the linear association. In the previous example here, we see that all these points, they are linearly going down. Okay, they're linearly going down. The overall trend is linearly decreasing. Okay, linearly decreasing. In the previous example here, this one, they're linearly going up. Okay, they're linearly going up in the if we can approximate the behavior with the help of a straight line. Okay, so the Pearson correlation coefficient tells us about the linear association between. So if you have perfect, this is called perfect linear association. Okay, so the Pearson correlation coefficient must be equal to 1. Okay, must be equal to 1 if you have perfect linear association. Similarly, this is perfect linear association between x and y variables. So in this case, because the line is going down, slope is negative, so your Pearson correlation coefficient will be -1. Okay, now if if there is a slight scatter, okay, in next example you will see here a slight scatter, but still they are overall their trend is linearly going up. Okay, so this is called strong positive relationship. Okay, and your Pearson correlation coefficient will be 9.9. Okay, so if your Pearson correlation coefficient is 0.9, so and looking at the scatter diagram, you can take the decision that yes, there is a strong positive relationship. Okay, similarly here you can see there is slight scatter, but overall they are going down. Okay, so this means that there is a strong negative relationship between x and y. Okay, but now look at this one. Too much scatter. Okay, too much scatter in x and y. Okay, and whenever we calculate the Pearson correlation coefficient, it comes out to be 0. Okay, it came out to be 0. So this indicates that by looking at the scatter diagram and the Pearson correlation coefficient, we concluded that there is no relationship between x and y. Okay, there is no association between x and y. Okay, now look at this one. The scatter diagram is showing that no relationship, too much scatter, too much scatter. But when we calculated the Pearson correlation coefficient, it was showing a weak relationship. Okay, so it indicates one important thing, that just looking at the scatter diagram and taking a decision, okay, concluding something from just looking at the scatter diagram is not sufficient. You have to look at the Pearson correlation coefficient. Might be scatter diagram is showing too much scattered and you cannot identify any association between x and y, but Pearson correlation coefficient is giving you some level of correlation. Okay, so looking at both is must. Okay, you the final conclusion you have to draw by looking at the Pearson correlation coefficient and the scatter diagram. Both the things are necessary. Okay, look at the next one. Look here. The scatter diagram is showing that there is a strong association between x and y, strong relationship. Okay, because all the points they lie on the line, but except there is one point which is 4, but overall they are very strongly correlated, yes. But whenever we calculated the Pearson correlation coefficient, it is showing a weak relationship. Why does it happen? Okay, why does it happen? Because the contribution, these are total 7 points. Okay, there are 7 points, and out of these 7 points, 1 point is too far. Okay, it is too far away from the rest of the 6. Okay, the contribution of this 1 point is very high, so that it makes your Pearson correlation coefficient to be in the weak category. Okay, so you can exclude that point. Okay, because if for example in this example you look only at the Pearson correlation coefficient and you say that there is weak relationship. No, there is no weak relationship. Okay, this weak relationship appears because of the 1 point, okay, which is outlier. Okay, so that's why the contribution of this outlier is very high on the Pearson correlation coefficient, so that's why it is 0.5. But if we look the rest of the points, they are very strongly correlated. Okay, so just looking at the Pearson correlation coefficient is not sufficient. Just looking at the scatter diagram is not sufficient. You have to look at both. The final decision must be based upon looking at both things. Yes, Amjad.
So, Doctor, what you will say for the يعني, at the end decision, what you will say?
We will say here for this example, okay, for specifically for this example, we will say that there is a strong relationship between x and y. Okay, we will say that there is a strong relationship because Pearson correlation coefficient is is getting deceived. Okay, it is getting deceived from this outlier. Okay, this outlier is actually its impact on the Pearson correlation coefficient makes the Pearson correlation coefficient to be to make it weak. Okay, but the scatter diagram is showing the exact behavior that all these points are strongly connected. They are strongly connected, but there is one outlier. Okay, so the mathematical Pearson correlation coefficient is getting deceived from from this point. Okay, so we will say that there is a strong relationship between x and y. So we don't look at the Pearson correlation coefficient in this specific example. Okay, so means to say, okay, actually what I want here to explain that the final decision must be based upon looking at both of them. Don't look one thing only. Okay, look at both the things. So here the scatter diagram is reflecting the means it is reflecting you means more I mean means it is more advisable. Okay, it has more means strength of the evidence. Okay, it has more evidence to tell you that what is the relationship. In the previous example here, if you look at the scatter diagram is showing you the no relationship. Okay, so in this example Pearson correlation coefficient tells us the relationship. Okay, so we have to look at the Pearson correlation coefficient. It is showing some degree of relationship, but the scatter diagram is not showing you that it cannot measure the relationship in this for this example. But Pearson correlation coefficient is measuring it is measuring and it's showing you the weak relationship. Okay, now look at this one, and this is very important thing here. Can you see, looking at the scatter diagram, can you see a relationship between x and y?
No.
Yes.
There is a
No.
relationship, very strong
First of all,
relationship.
first of all,
Going
decreasing,
down,
then increasing.
yes, exactly. So you can see here they are very strongly correlated. Okay, very strongly correlated, but this relationship is non-linear. Okay, it is not linear relationship. Okay, now look, scatter diagram is showing us a relationship, but the Pearson correlation coefficient for this example is 0. Why this happens? Why this happens? You
Because
know,
it's just for the
yes,
linear.
yes, because it estimates the linear association between x and y, and in this example there is the data shows no linear association. So Pearson correlation coefficient is 0. It cannot estimate the non-linear association between x and y. Okay, so if you have a data like this, okay, you have a table like this, x and y, and okay, you have the data like that, and you calculate just Pearson correlation coefficient and you say that there is no relationship between x and y, your answer will be wrong. Okay, you have to look at the scatter diagram and then you will tell that there is no linear u-shaped correlation between x and y. Okay, so just concluding here the discussion, whole discussion here, sometimes or always, okay, always look at the scatter diagram and the Pearson correlation coefficient to take the decision. Okay, don't take the decision by looking at the Pearson correlation coefficient only or by looking at the scatter diagram only. Okay, sometimes scatter diagram will deceive you. Okay, and sometimes Pearson correlation coefficient only, if you look at that, it will deceive you. Okay, so we have to look at both the things and then the final decision is the based upon the uh, the evidence we get from both the methods. Okay, Pearson correlation coefficient and the scatter diagram. Yes, Amjad.
But doctor, what I see or what I hear from you that you decide, for example, in the I think previous slide, that because one of the points just is too far, you decide that it's a strong relationship.
Yes, yes.
So you first of all you decide from the graph if the graph is clear. Then if the graph is not clear, you go to the correlation.
Okay, okay. Look. One thing from the graph, can you measure the relationship?
Uh, yeah,
No.
majority by number. You mean?
Look, you can visualize. You cannot measure. Okay, from the graph you can visualize only. You cannot measure. Okay, from the graph you can say increasing, yes, overall increasing, overall decreasing. But if the question is, for example, here, in this example, yes, here, can you measure how these two are correlated? We cannot. We can visualize, yes, overall they are decreasing, but how strongly they are decreasing? Okay, we have to calculate the Pearson correlation coefficient. So we look both the things together. Okay, it is not so that you will just calculate the scatter diagram, and by looking at the diagram you will decide. No, you have to calculate the scatter diagram, plus you have to calculate the Pearson correlation coefficient as well. Okay, so because scatter diagram is the visualization, Pearson correlation coefficient is the measurement. Okay, it tells you the number, that with the help of number you can measure the strength. The scatter diagram will not or cannot measure. It can visualize only. Okay, so visualization and the measurement, both things are important in taking the final decision. So this is the actually what I want to explain. Okay, the last thing is just the representation of the Pearson correlation coefficient in terms of percentage. This is called the coefficient of determination. Okay, the coefficient of determination is nothing. It is just the Pearson correlation coefficient in terms of percentage. Okay, so how to calculate it? We take its square and multiply it by 100. So we get the answer in this way. So for example, here you have the Pearson correlation coefficient 0.923. And if the question is calculate the coefficient of determination, so what we need to do, we will just multiply, we will just take its square. Okay, means we take its square and multiply it by 100. So once we do that thing, we get here the answer 85.19%. So now you can represent your answer in terms of percentage. So what is meaning of this percentage? This means that the variation of y can predict 85% of the y values. Okay, 85.19% of the y values can be predicted from variation in x. Okay, so in this way you can predict, you can analyze this percentage. So the analysis is 85.19% of the variation in ice cream sales can be predicted by the variation in the temperature. Okay, so means if you subtract it from 100, so 14%, around 14 or 15%, you can say the values of y can are not predictable from the variation in the temperature. So you can say that is the error analysis. Okay, so error in the prediction. Okay, the error in the prediction of y, okay, is 15%, you can say around 15%. So these are the questions you can do at home. Um and we will do some questions next time. Okay, we stop here. And in the meanwhile, I will just take the attendance. If you have any questions,